In this lesson, we'll talk about passing data to a function. Now, if you recall, you were passing data to the function POW. And so you would pass it the base and you would pass it the exponent that you wanted to raise the base to. Order does matter when the function is defined to take values. And so the function header defines how the values will be accepted in terms of order so that it knows how to use them in the body of the function. So when sending data to a function, we pass them by what we call arguments. So the arguments A and B are being passed to the function. Now, only copies of whatever A and B are passed to the function. Then it uses A as the base, okay, B as the exponent. The algorithm processes them and returns them back to assign them to C. We call these parameters as well. So I might use the word actual parameters. That's also known as the arguments. The formal parameters are what actually are in the function header. So here we can see num is the parameter, and it is specifically of integer type. When I make the function call, that would be the argument, the actual value of what num will take on. So what happens is num is going to take on a copy of what is passed during the function call. And so see out the value is, and so num is representing whatever that value was from the calling function, whether it's an actual number or if it is a variable that represents a number. So we're passing them by value. It's taking on a copy and it's going to use that in the function. The integer value num is the parameter and accepts any integer value passed to the function. I cannot pass a double to be placed inside of an integer variable. That's something to keep in mind. So here's an example of the function call. It is void, so we don't have it setting it equal to anything because it's not returning anything. So it is passing an integer value 5. And so num is going to represent that value of 5. And so num is going to then be used in the function execution, passing it the 5, and it's going to print 5 to the screen. Here's one where it is taking multiple values. So the function call, passing it value 1, value 2, value 3, and in the signature of the function show sum, num1, num2, num3 represent a copy of whatever value 1, value 2, and value 3 equaled in the function that called it. And so it will sum those three values together. Now, what you need to understand is that num1, num2, and num3 are local variables. Once the body of this function is done executing, num1, num2, and num3 are destroyed in memory. They only last for the sake of the executing function. I cannot access num1, num2, num3 outside of the function show sum. All right, value 1, value 2, value 3 will still maintain the value of what they were given. So let's say it represented a 2, 3, and 4 in memory. They still retain the value of 2, 3, and 4 in those variables. It's just that it will print out a 9 to the screen. So here we have int value 5. It is passing a 5, and so in memory 5 is the value of VAL, and it is passing that by what we call value. When we pass by value, we're only passing a copy of whatever VAL is. I can't change VAL and what it's going to represent in memory within the body of the function call even or odd. I can use that value in the body, but it will have no effect on the actual VAL stored in memory when I pass by value. I can't actually change it. I can change it in the function, in the main function, but the function to call to even or odd cannot actually physically change what is stored in the variable val. I can return a value from a function, so we can do this a couple ways. We did this with the idea again of the POW being passed some values and storing it into X. All right, so it's returning that value to the function. So here we can see it's taking num1, num2, which is going to represent whatever was passed from the main function. It's going to set a local variable. This is a local variable only used for the sake of the executing function. Let's result equal num1 plus num2 and returns the result. So that's one way to do that, where I created a local variable, came up with a value, and then returned that value through the variable result. Once the return statement executes, result is destroyed in memory, and so is num1 and num2. Another way to do that is, here we have double result. Again, num1, num2, returning result. Because it's returning an integer, we have an error because result is a double. Okay, this has to return an integer. It can't return a double. So they have to be compatible data types. So that's something to keep in mind, that this would produce for us an error. Another way that I can return a value, instead of creating that local variable result, I can actually return the sum, the expression, without having to set it to a variable. So this will take a copy of num1, num2, add it together, and return that to the calling function. So here's a call to square. Here is a function that takes a, in this case, a radius. The copy of radius is being passed and being held in the variable number, which is a local variable. And so this is going to return number times number. And so it is going to set it, return and store it right here, multiply it by pi, and set it then equal to area. So here we can see an example. Here I have a function prototype. So we have a function called isEven. It's going to get a number from the user. So the user is going to enter a value, and it's going to be stored in the variable VAL. And so here they're calling to see whether or not, so VAL returns a bool, a true or false. And so here we can see the pass of, so since if statements use true or false to determine whether or not it wants to execute, you can see that they actually passed a call to isValue passing it VAL. And so VAL is going to pass a copy, which I don't have here. It's going to pass, it's going to determine whether or not VAL is even or not, and whether or not it returns a true. If it's true, if it passes a bool value of true, it will print isEven. If it returns something other than true, it will say that it is odd. So let's revisit variable scope. I talked about local scope as it was related to the body of a function. And so local scope is when the variable is accessible, remember, only within the function that is executing. The variable then is destroyed when the function completes execution, returns control back to the calling function. Local variables may be placeholders for data while a function is executing, but otherwise would not be needed outside of the function. Now remember, we have variables declared to global scope. So I actually can declare variables to have global scope up here, you know, where maybe I have int x is equal to 1. And so he would have global scope throughout all of the functions versus the ones that are declared inside of the body of a function. This still has local scope to the main function. VAL is not accessible to the function isEven The only way isEven can get a copy of VAL is by me passing it as a parameter, unless I declare it to be of global scope. And we talked that we do that with, a great deal of scrutiny. Not everything should be declared that way. So the only way that a function can get a variable that is not local to the function is through passing it as a parameter. And so that's important to understand. There are these things called static local variables. I did tell you that a local variable is destroyed after the body of the function is executed unless I give it static designation. So a static local variable retains its value while the whole program is executing. Okay, so once it's initialized, it will retain its value while the whole program is executing. So for instance, I could create a static local variable that every time I call on a specific function, I could create a tally and figure out how many times that function was called while the program was executing. So here, when I make my first call to show static, we can see that stat num is executing. So every time that I would ever make a call to show static, it is incrementing stat num, and it's going to retain that as long as the program's executing. Once I terminate the program altogether, and close it out, it loses its value until I call on, open up the program, re-execute the program, and ask for this call to show static. Passing by reference. So we talked about passing by value, where I passed a copy of the variable to the function. But passing by reference allows me to change the original variable in memory, its value, after the function is done executing. And we do that by using an ampersand to indicate that these variables that I am taking copies of in here, if I change these variables in the body of the function, they will be reflected back in the calling function. So it would actually change those values in memory. When I pass by value, that did not happen. num1, num2 kept their value in our previous function. But if I pass by reference, then any changes I make to the variable will also be reflected back in the program, and we use the ampersand to indicate that. So for example here, this indicates that double num is going to take a variable, pass it by reference, okay, so that anything that I do to that variable, it is going to also be reflected back to the calling program. So value is equal to 4. In main, value is 4. Now calling on double num, so they're going to make a call. So it's going to pass 4 through the variable value to the calling program. So let's take a look at what's happening in double num. We passed it as a reference variable. That's what the ampersand is indicating. So what happens here is it lets reference variable equal reference variable times 2. So remember, we called and passed it a 4. Okay, and so reference variable is going to be multiplied by 2. And so when it calls to print value again, after the function call, value in memory was updated to be an 8. If I passed by value, we wouldn't have the ampersand, and I couldn't make that change in memory. It would still print for us a 4. But when I use the ampersand, it is going to pass it by reference. So any changes to this variable will be reflected back in the variable that was passed in value, and so we'll get an 8 out to the screen. Function overloading is when there's more than one function with the same name, but the parameter list is different. The difference might be in the data type listing, the return type, and the type of parameters. So here we see a couple examples of overloading. They're all called get dimensions, but the difference here is the parameter list, the types, the order, and so forth.